Good morning, everyone, and welcome to this week's installment of GeoTalks Express, where we're going to be talking about what's new in Global Mapper Pro version 26. Welcome back to those of you who were here last week to look at the new features Mackenzie and I discussed in standard version of version 26. Mackenzie is joining me again today, and we're going to talk about some new things in Global Mapper Pro. How are you, Mackenzie?
I am great this morning, Jeff, and I'm happy to be here and talk about some exciting new stuff in Global Mapper Pro. Some great new features.
Awesome, sounds good. Well, let's go ahead and try to get into it. As always, just a quick mention, our attendees are in listen-only mode for our webinars. Please use the questions panel if you want to send us any questions or comments. We'll do our best to answer those live, and if we can't, we'll follow up afterwards. As always, this session is also being recorded, so if you are signed up for it, you should get an email, I think, when that recording posts to our YouTube channel. The QR code on your screen right now will also take you to the Blue Marble Geographics YouTube page. There's a ton of great content up there if you're looking for any other types of, information, tips and tricks and things like that. For the remainder of the year, the Blue Marble calendar is very busy. If you are someone who is looking for training, we have training across all our platforms. We'll have a live online geodesy training. So if you're someone who works with Geographic Calculator or geodetics, take a look at that. We have in-person Global Mapper and LiDAR training in Calgary. And then we have live online Global Mapper training that'll cover geospatial analysis. That's a standard, intro to Global Mapper, terrain analysis, and LiDAR processing. Take a look at our self-training as well, available through the QR code there. We have some free introductory self-training, and they'll also be coming soon once Mac and I write it. There'll be kind of written up workflows highlighting what's new in version 26, so you can follow along with similar to what we're talking about today and what we talked about last week. Any of you affiliated with colleges, universities, academic programs, worth noting we have our own academic labs we provide and year-long access to our apps for schools in the listed locations there. So follow up for more on that if that's of interest to you. And I think otherwise that's all the kind of housekeeping stuff. Let's get in and take a look at what we're going to be discussing today. So Global Mapper Pro in version 26 has a variety of new features and updates to existing features. We're going to talk about solar analysis. So, utilizing 3D data for understanding where sun and shadows are. That's a new tool. We'll look at a variety of point cloud analysis updates, things that have been very heavily customer driven as this tool continues to evolve and get great customer feedback. We'll talk about some continued updates to pixels to points, and then we'll wrap up taking a look at the new insight and learning engine that has some of our new deep learning tools in it. And so with that, I think, Mac, I'll let you take the screen and start us off.
All right, that sounds great. Just give me a moment, folks, to share my screen. Make sure I am sharing the correct one. And we should see Global Mapper open. So I will be first taking the first bullet in that list that just went over of our exciting new features in Global Mapper Pro. And this is going to be the solar shadow analysis. So the data set that we're working with for this to find the shadow and sun areas is a ballpark for a minor league baseball team in Omaha. So this is just a little ballpark. It's, of course, got some buildings, some infrastructure around it. OpenStreetMaps here is just giving us a little context what we're looking at. I also have a high-resolution terrain grid for this area, so we can see the slope of the stands, that flat area where the diamond is, and all the surrounding areas as well. In addition to this 3D terrain, I have some building features. Now I'll grab my feature info tool and click on one of these buildings, and you can see I've added some elevation attributes. These are pulled from a point cloud for these extracted building footprints, and allows me to sort of see these buildings at their given height and use that in the analysis process. So the solar shadow tool in Global Mapper is up on the analysis toolbar, and what this does is finds the areas where there are shadows based on a time and a date. I'll go ahead and open this tool and we'll explore a bunch of these options in the dialog. Now, the input data for this is going to be terrain data, so a raster elevation surface, a digital terrain model. And then you have the option to add in some vector features. So 3D vectors features here. We've got our layer of buildings that we just saw had some elevations associated with them. I'm going to choose to extrude those 3D areas from that elevation value we looked at to the ground, so it's like a solid building. And that's going to be our input data. Now, the analysis, the right side of our dialog here, we're going to specify what time we want to look at, the date and time for how we want to view these shadows. We have some options here to only calculate the shadow coverage at the specified start time, so this top entry, or to calculate over a range of times and dates at an interval in seconds, minutes, hours, or days, depending on how lengthy that interval is. So I'll start running this tool just for a single time, and let's choose 6 p.m. on the 26th of September. I think that was the last home game here for the Omaha Storm Chasers. In addition to setting the time here, I need to set the offset from UTC time, so that's -5 for this central daylight time zone, I believe, that this data is in. Once I set up the time range, we have options to specify the heights to calculate the shadows at. So, how far off the ground do you want to be, looking for these shadows? And then at the bottom, we have the outputs. Now, this tool can give us a variety of outputs. We can save a shadow percent as a grid, or a shadow count, for going over a length of time, analyzing multiple intervals there. We also have the option to save a shadow mask layer. So this is going to be a layer that is going to look like shadows on our data set. We'll take a look at this last checkbox in a minute here, but I'm going to save just a shadow mask and our shadow percent, and click OK for our single time. Global Mapper is going to go through. This shadow percent map isn't looking like too much since we've only analyzed one slice of time here. But turning that off, we can see our shadow mask, and it's starting to look, we've got shadows from these buildings showing on our ballpark. So at the start of this last home game for this baseball team, for the season, this is what the shadows would approximately look like. We can see sitting right behind home plate, you're going to be in the shade. Maybe you want a little bit of sun, seeing as this is a late September game. I'll go back to this tool, turn off those generated layers, go back into the solar analysis tool, and we'll take a look at calculating the shadow masks over a range of times. So I will set this, let's say, for a few hours on this single date, the 26th of September of this year. So we'll go from 6 p.m. to say 9 p.m. We're going to calculate and create a layer showing the shadows every 15 minutes, let's say. Make sure I have those options selected, make sure I've got my input data selected appropriately. And then I still want to create that shadow percent map. I still want to create a shadow mask for each timestamp, but I want to take those individual shadow mask layers and create an animation series from them. So we're going to create all the outputs here, click OK. Global Mapper is going to take just a second longer to do this processing since we're creating these shadows at multiple intervals. And we can see this shadow percent map looks a little different. We've got a custom shadow shader applied here. We can see the deepest blue areas are places that are always in the shade. And then, you know, we see those shadows grow just in this percent map. Since I chose to create an animation and a layer for each interval that we're doing the analysis for here, I have a group of layers listed in blue, indicating that they are part of an animation. And I can come up to the animate toolbar, which has the play, stop, and then our speed buttons here. And I just click play, and Global Mapper shows me this animation. Now our tortoise and hare buttons will slow down or speed up the animation between these layers, but it allows us to see how those shadows change over time, taking a look at those different snapshots, in our case, every 15 minutes. So this is a really cool tool to be able to find the shadows for an area. You know, I'm doing a little bit of a sillier use case here, looking at the shadows at a ballpark, but you can do this analysis, you know, looking to find optimal placement for solar panels, and looking at, you know, where over the course of a day, over the course of a year or a season, you're going to get the most sun in a particular area. So quite a powerful tool, and makes some really cool outputs for our data, a little animation as well as some, you know, layers that can be used in further analysis.
Mackenzie, we had a question come in that you could elaborate on a little bit. It was asking whether or not, or I guess it was asking where this terrain layer you're working with was created. Was it, you know, from pixels to points? Was it a point cloud? Where did it come from? And then does the tool care where the data or how the data was created?
That's a great question. So I'll start with the second part of that. The tool does not care where the digital elevation model comes from. Global Mapper is very data driven, and it's going to see this, you know, raster pixel based elevation data and say, all right, I can work with that. I can analyze that. This particular data set, I pulled down some point cloud data, I believe from the USGS, and classified ground, classified buildings in order to extract and get the polygons that we're seeing here, and then created a digital terrain model from the ground classified points in this data set. So this did come from LiDAR data, and all the processing on it was done in Global Mapper. But again, wherever you are able to get the elevation, the terrain data, Global Mapper will be able to look at it and process with it, use this and any other terrain analysis tool.
And I'll throw one more question your way that just came in. Someone asked if you could use a digital surface model rather than a digital terrain model and not use vector data.
Absolutely, you can. That digital surface model, just as a hill would block sunshine at certain times of the day, you know, if you had a building captured within that raster surface model data, it would create a shadow just the same. Again, Global Mapper is just going to see those elevation values and calculate based on that. The program doesn't really care what you're capturing in that data, just that the data is there, and it's going to look at all of it.
Yep, absolutely. Alrighty, thanks for walking us through that, Mac. I think I will go ahead and take this screen and we'll shift gears a little and start talking about some point cloud analysis updates when my screen share is ready to go here. So when this kicks over, you should all be seeing Global Mapper now. And we're going to take a look at some new updates in relation to point cloud or LiDAR analysis. I have a point cloud loaded here that we're looking at, and on the right-hand side of my screen, you'll see that I have our automatic point cloud analysis tool open, and that's kind of where we do the vast majority of our point cloud and LiDAR related work. And this tool has been, you know, continuing to expand over the past few years. We now have, I'm sure many of you are familiar, we have the ability to custom train classification. So you want to find something custom. We're going to look at an update to that today. And one of the new features we have in here now is the ability to identify the model key point flag within a point cloud. And so you'll see that's a new section here where my cursor is. So model key points are points identified in a point cloud that allow us to reduce the size of the point cloud while retaining important structure and important characteristics where the point cloud needs to retain detail. Most often, this is done so that we can work with a more manageably sized point cloud, especially for those of us who end up working in a non-GIS software after we do our point cloud analysis. So maybe we're moving over to a CAD environment or some type of other rendering environment that doesn't handle massive point clouds as well as Global Mapper or another GIS might. And so model key points are interesting because they can be handled a variety of ways, both related to the LAS spec and kind of independent of that. And so what we did was we allowed the flexibility when users identify them to identify them really however they want and make the product that they want for their next steps of usage. So the first thing that we care about is how we're reducing our point cloud. And I'm going to go ahead and set these values and we'll talk about them a little bit. Reduction level is an estimate, but it's how much we're reducing the size of the point cloud. Obviously, depending on the structure of individual features in the point cloud, that's going to vary a little. So we'll see how close we get here. And then this maximum face angle setting is just when it's looking at the structure of an object, we're saying, okay, you can allow up to, in this case, I have an angle of 45 degrees here. Beyond that, we're going to consider that a different object. And then in terms of what we create, there's a variety of ways and a variety of products that we can create from this process. We can overwrite existing model key point values if we want, if there are any. We can also create a new layer, and that layer will contain just the model key points and then a layer with the vector tin. We could choose to select the points if we wanted, and we could also choose to identify them as a classification rather than a flag. The point here being, if you choose to do it as a flag to the point, you are not losing the classification value of the point. We'll see in a second, this point cloud is already classified. So I don't want to overwrite that information. I want to have the point flag as the key point. So we'll go ahead and run this. This should be pretty quick. I ran this earlier. I should have kicked it off while we were talking. But so what we're going to make here when this process completes will be a new set of a new point layer and then also a tin. We probably won't render the tin because it's massive and waiting for it, takes some time while I'm sharing my screen. But we'll look at the point cloud and then we'll also look at the existing point cloud and see how that has changed as well. Because what we're doing is adding some new information to the existing point cloud while also creating a specified data set that we're working with here. We'll give that just a second to wrap up. Of course, I test this beforehand. It goes nice and fast, and then I have all my screen sharing going, and it's a little slower, but that's okay. And while that's running here, maybe we'll go ahead and take a look at the color options because I saved those earlier, and those should still be here. And we'll go ahead and so from this LiDAR dropdown, which is actually really handy, although it really just talks about how we display our data, it lets us see a large amount of information about our point cloud, and it gives us a whole bunch of ways to visualize our point clouds depending on what attributes and values we want to deal with. In this case, we want to look at the key point flag. And what we'll see here is that red points are considered key points based on the parameters I entered. So they're important to retaining the structure of our data set. And you'll even be able to really pick out unique objects and unique features, right? We can see trees very clearly, right? We don't necessarily get building or structure roof features when the roofs are flat. We can even see power lines were retained, right? So these are objects that within the tolerances that I set are important to retaining the general structure of the point cloud. Blue points then are not model key points. Most common that ends up being ground and flat surfaces that if you interpolate across them, they're flat anyway, so it doesn't necessarily matter. We'll go back to looking at this by color. My output layers here, so I have now a model key point output layer, and we'll see effectively this is then those red points that we looked at in the original layer. This is just the model key points, the points again that we are concerned with, and you'll see it's roughly, we reduced by 50%, so it's in the ballpark of about 50% smaller than the original point cloud by point count. And again, that value is probably a little higher because we have so many 3D structures here, all these trees, right? We need to have retained. And then we have a vector tin as well, one large tin. I'm not going to take the time to render that now, but that's here too. And you could further simplify, refine that, and work with that as you need to as well. So I had mentioned that this point cloud is already classified. And we'll color by that and then talk about some of the classification process. So I classified this earlier. And for those of you who've been working with our tools know for a while that the classification is based on spectral partitioning or what's often called segmentation. And so when we run an automatic classifier, what happens under the hood is the point cloud gets segmented. Now ignore this crazy area for a second. We're going to get there. What you'll see here then is some very distinct things, right? We have segments representing our trees and our ground surface, and then all of our buildings. And that is kind of what got us to our basic, classification. We have grounds, buildings, power lines, all that stuff. What we care about though, and what is new is the ability to build custom classifications. That's been around for about a year. And then to save and reload them into the application. And that's what we're going to look at here because I did that already, to save us a little time. When we attempt to make a custom classification, what we want to work with is the segments. And so obviously these segments already exist. But what I did, and my goal here was attempting to find the dirt roads. So if I color this by RGB, you'll see, right, we have dirt roads here, and I wanted to see if we could pick them out of the point cloud and classify them. So when we attempt to train and build a custom class, we generally want to select by segment because the process of segmentation gives us a variety of output statistics. So what I did was I refined my segmentation process. In this case, I just tried off of color to identify segments of the road. And I already did this earlier, but I wanted to show this tool. I had restricted my bounds, so that's why we see the hard rectangular boundary here, just for the sake of time, and I really wanted to specify in on the roads. So I can see all these different segments. That's great. And I can now use those segments to train a custom class. Again, this has existed for about a year now. This in itself is not new, but let's say I've taken the time and I select some segments and I collect a sample. Maybe I add it to my custom class. Now I can go through and do this a couple times, et cetera, et cetera. Or let's say I've done it previously, I can go ahead and load the parameters of an existing trained class. Now we'll see I have my dirt road class here. It's already been trained, so all the statistics associated with it are saved and loaded. Again, we don't necessarily care what those are, as raw number values, but they're here, they're calculated from my work earlier. My subclass setting is retained. So subclass is when I'm refining or re-identifying a already existing class, right? So our roads traditionally are going to be part of ground. So I wanted to reclassify the ground. We'll see now that that model exists, I can use it as the basis of a classification. and I could rerun the classifier and use that classification. Now we're not going to wait for that live. And if you were paying attention earlier, you probably noticed that I have some dirt roads classified based on this custom class already. Let me clear my selection there, and we'll see the purple areas are areas, the color that I just gave to those dirt road classes, and we can see it does a really good job of following where those roads exist. So now what I've done is I've given a new custom classification the ability to be saved and loaded in and out of the application, shared between users, between sessions. Maybe you're just simply saving progress, right? Maybe I come back later and I want to edit this. I could collect more samples, add them to the dirt roads class. Maybe I don't like the work I did earlier and retrain it, save it again, reload it for later, and go back and forth. So this is a great way to kind of continue that work, share that work, and further refine all that custom analysis that you've been doing in the tool as you work through the custom classification process. One last update on point cloud stuff here before I send things back over to Mackenzie. We're going to look at some new LiDAR QC updates. And I'll just go back to looking at this data by elevation. In fact, I don't probably need this open either anymore. So for a while, we have had a LiDAR QC tool. It allows you to adjust your point cloud elevations based on control points. So I have a control point layer here, and these are 3D vector points, and each one has an elevation value associated with it. So I have a set of 10 control points throughout this data set, and I'm going to use them as the basis of an adjustment of my point cloud. Earlier, I made a terrain model here just for the sake of reference. So this terrain model is explicitly derived from this point cloud, filtered to ground. It's purely a visual reference for a before and after. But let's go ahead and take a look. Let me bring this on screen here. So right now we'll see that point cloud ground surface sits more or less right on the ground DTM that I made from the point cloud. What we're going to do is apply a shift to the point cloud, and then we'll see how that visually looks offset from the older terrain data set. So that's why I have that here. In the LiDAR QC tool, we have some new methods as to how users may want to adjust their point cloud. So when you open the tool, you'll see all of your statistics in terms of how your point cloud deviates from the control points. And we have a new option for fitting to a best fit plane. What this does effectively is creates a best fit plane three-dimensionally around each control point and applies the shift in that regard. So this is a new way to do that. And when we apply our fit, we are asked if we want to confirm. You don't see much visually because the original point cloud was adjusted, but if we take a look at our new, we'll draw a similar profile, now we'll see that, so the offset was generally down to the control point, so the point cloud was shifted down. Well, then this terrain surface just represents where it was originally. So we can now visually see that the entire point cloud has been shifted to match with the GCPs. As always, this is saved in your workspace for now. The original file hasn't been updated unless you were to go and export that out of the application. Saving the workspace would work within the relative scope of the workspace as well, but that's about the extent of it there. Any questions come in there, Mac, while I was talking away? I know I was talking for a bit there.
You were, but you did a great job explaining everything. We didn't get too many questions coming in, which, I hope people are just, really excited about these features and seeing the demos, just paying too much attention to ask any questions. But if folks do have questions, please throw them in that questions panel. I think it's my turn to take the screen back, and we'll talk a little bit about pixels to points.
Sounds good. Yeah, go for it.
All right. Well, I'm, choosing to share my screen here. I'll just mention that I, really like the ability to load and share, save the custom trained point cloud classes. Here at Blue Marble, we're always passing test data sets around and exploring new data options and working collaboratively. So having that option there within the automatic point cloud classification tool is great. It's really key and a very powerful little add to that tool. So now that I've got my screen up, we're looking at Global Mapper once again, a different data set this time. For those of you who may be familiar, you may recognize these as geotagged image points or picture points as we call them. And this is a subset from a drone flight that some folks here at Blue Marble Geographics completed. And in this workspace, we also have some ground control points. I've just got 3 ground control points relating to some of these images here, again, a subset from a larger flight that was completed. And a few of the updates to pixels to points, which is a really powerful tool for taking these geotagged drone or UAV collected images and transforming them into a 3D point cloud, a seamless ortho image, and a 3D mesh feature. Updates to this tool include some speed processing improvements. We'll touch on that and look at some data points there later. And also some improvements to the automatic ground control placement aspect of this tool. So I'm going to start by grabbing my feature info tool in Global Mapper and clicking on one of my picture points. Now, this is a ground covered polygon that we're seeing in Global Mapper. And we'll notice that it is a slightly trapezoid shape as opposed to a rectangle. And that is because Global Mapper has improved the way in which these covered polygons are calculated to sort of better approximate the actual ground coverage based on all of the camera parameters that are captured when an image is taken with the drone and camera hardware that is available. Additionally, with the feature info tool, we of course can see the image, and we can see in this image we've got our ground control targets. If I zoom in, we've got one over here, and then on the other side of the image, we have another ground control target. Now, we have, I think, 39 images here. I'm going to bring up my pixels to points window that I've already done a little bit of work in here. I've loaded in my 39 loaded drone collected images. I can look at those in the preview window, zoom around. But the automatic ground control point placement is accessed with this ground control points button here. And what this does is allows me to define what my ground control point target looks like. And this could be, a target that is something I've placed in the field. Like in this data set, we've got these, man-made targets, something commercially available, something homemade, but this could also be, a distinct corner of a curb, where two lines meet in a parking lot. These could be natural features that are static within the area, able to be surveyed, to collect that ground control point coordinate information, and then, of course, identifiable in the images. But what I've done here so far in this pixels to points workspace is defined what this ground control point 2 looks like in just one of my images. And Global Mapper says, okay, this is what this looks like. Place the control point here, and then Global Mapper finds where all the other control point 2 points lie in this set of images. Confirmed points that I've looked at, this one, what I use to identify the target, has a checkbox. It's been confirmed. That is the correct control point. Everything else is just auto-placed in green here. Now we can see that Global Mapper's done a real good job auto-placing these points. If we look at this particular image and zoom out a little further, again, we have a case where we've got 2 control point targets. Now these control point targets look very similar. Global Mapper isn't actually looking at the number on these control point targets to really figure out which one is the control point that I've identified in this image. Global Mapper is using the coordinate location of the control point, and then that more accurately projected ground coverage polygon, some pixel matching, and other analysis measures in order to identify that, the ground control point I identified in my first image is this ground control point in my second image here, and not this other control point that is also captured. So what I would do in this workflow is go down the list, taking a look, making sure these control points are placed well in the center of my target, confirming the location in each of these images. Again, all of the green listed images here are auto-placed. Blue means I've confirmed that position, and yellow means that there might be a control point popping up in that image. Global Mapper wasn't able to find one in order to auto-place something. We can see, like in this image, we've got a ground control point. It's actually not the correct ground control point. Our ground control point 2 is off in this direction. So again, Global Mapper gives us a little bit of a buffer around these ground control points and coverage polygons to say, hey, double check this list of possible overlap images, place that control point manually if needed. But the bulk of this work is done with that automatic placement. Now I've done this for ground control point 2. I've got 2 other ground control points in this data set that I would go through and do that same workflow with. Find an image where the ground control point is represented well, define the target in the image, and Global Mapper would go through, auto place the points, and I would just go through and confirm them. It is a great tool for speeding up the use of ground control points with the pixels to points tool, which ultimately improves the accuracy of the generated outputs. And with the improvements in version 26, this automatic placement has become much more refined. We're able to handle those situations where there are multiple ground control points captured in a single image, and we're able to better find and accurately place ground control points for non-standard targets. So maybe not this bold high-vis target, but something a little more subtle that's just part of the natural environment there. So great improvements to the pixels to points tool. Once I'm done picking all these ground control points, I just close this window. All of that information is saved. I can, of course, return to it if I need to for any reason. And I'd continue on setting up the options for the pixels to points process. Now, it would be a little silly to talk all this time about pixels to points without actually showing it output for just this small little data set. So I did do a little processing. This 39 images took about 2.5 minutes to run on my computer this morning. But we've got our point cloud as an output to the pixels to points tool. We can see our orange ground control points popping up right on our targets. So we've got that well placed and adjusted, at least horizontally. And then we've got our generated ortho image, a very high resolution image for this little area in downtown Hollowell. So a lot going on with the pixels to points tool. We're trying to make it easier to use, increasing the accuracy of the outputs through the use of ground control points, making that easier for users to incorporate, and just generally improving the tool so that better outputs are created with each version of Global Mapper.
So Mac, while you were talking, we had a few questions come in that I thought I would address here. Somebody asked about RTK support without ground control points and in pixel to points. And the answer to that is, as long as your imagery has that information associated with it, Global Mapper will utilize it when running pixels to points. There is also the option, there's a right-click menu in there where you can import values from an external file. I think Mac's bringing that up on screen now. So if you happen to have that information in an external file, you could also load that in as well. One of the things we're working on for upcoming releases that I see a question pertaining to is looking at multispectral and multi-band imagery processing in pixels to points as well. So if you're someone who's working with maybe infrared, near infrared, thermal, whatever the case may be, We're actively reviewing that now too. All right, I think that's everything here. Sorry to cut you off there, Mackenzie.
No, no worries. That is all that I had to show in this workspace. If you want to bring up a slide,
Hmm.
Jeff, we can talk a little bit about the
Yeah.
processing speed improvements in pixels to points for
Okay.
version 26. So this isn't, a demo where we're looking at data in the program, because sitting and comparing the processing time for pixels to points would make a very long and possibly not so interesting webinar. But I've got some data on screen here, just showing a sample of some speed testing that we conducted internally, comparing version 25.1 to the improvements we made to the pixels to points tool and processes in 26.0. So in this table, I have the number of images we're working with, the total size of that input image set, and then the percent decrease in processing time. So, we can see that we have pretty significant reductions in processing time. We've sped up this process, made it more efficient, without compromising the accuracy and integrity of the outputs. We did, I see, get a question asking about, using some bigger data, some larger image sets. And as you can see from just this small collection of data points, that's part of a much larger set we conducted internally. Pixels to points can handle many different, counts of images and sizes of input data. So there's not too much more to say about that, but if you are someone who is creating point cloud, ortho image, mesh outputs from pixels to points, you should be seeing some reduction in the processing time, some improvement to that processing speed in version 26.0. So if you're doing that a lot, I definitely recommend upgrading if you haven't already.
We had a good question come in, Mac, about the types of ground control points, shape, color, et cetera, et cetera. I don't know if you want to speak to that a little bit.
The types of ground control targets, the
Sorry,
like
yes,
visual
that
points
can
in the
be that
images.
can be identified. Yeah, yeah.
Yeah, of course. So, global mapper, obviously you need something that's visually recognizable in the image. That's sort of a given. Uh, the targets that I showed in the sample data here, these are, commercially available targets that fold out, and they're high vis. They're pretty easy to identify in the data set. You can of course use those. Global Mapper is going to work with those. They're easy to identify. But you can also, spray paint an X on the ground, an X on a piece of plywood, and place that in the field. Or, as I mentioned, you can use the corner of a distinct feature, like, where some lines meet in a parking lot, or a distinct marker on the ground. Um, Global Mapper, runs through some image analysis in order to find those control points and place them. That is helped by the coordinate location of the surveyed control point and those image coverage polygons, the way the pixels are distributed in the source images. So there is a little guidance spatially there. But I would generally say that as long as your targets, whatever you're using as the target in the area for those ground control point locations, are easy to be recognized in the image, Global Mapper should be able to find them with the automatic GCP placement tool and place those fairly accurately.
Yep. And just as a side note, I've worked with some customer data, where within the same flight they used GCPs that were the paint markings on a tennis court, a manhole cover, the corner of a sidewalk, and a sprinkler head in the field. And it could find all of those. Just as Mackenzie said, the relationship of the unique object and where it is in the image, it does a really good job of finding all of that. And I wonder, Mac, if maybe we should see if we can use that data set when we write our um, what's new free trading course, so people can see that in action.
Yeah, that's a great idea.
And
And
we'll have
I'm
to.
glad you mentioned that. Jeff and I are working on writing up some of these workflows to provide with data to you guys if you want to explore some of these new tools, but don't necessarily have the appropriate data to do so. So we can definitely try to use the data set that Jeff mentioned.
Yep. Alrighty, we'll keep PowerPoint open here. We'll switch gears to our last topic, the Global Mapper Insight and Learning Engine. So this is our newest feature addition module to the application that we have introduced probably in a long time. Right now, the Insight and Learning Engine is deep learning powered, focusing on image analysis tools. It has a variety of built-in models for land cover classification, building extraction, and vehicle detection. There are also options to fine-tune or adjust built-in models, and then fully retrain an existing model as well. This is currently in beta, so you'll see when we look at it today, um, the three options we have: land cover classification, building extraction, vehicle detection. If you're someone who works in with this data or is interested in working with these models, keep an eye out for subsequent updates, additions to models, and things like that as time progresses. In terms of licensing and accessing the Insight and Learning Engine, it is included with Global Mapper Pro version 26. So if you have a version 26 Pro license, active maintenance and support, you'll automatically be able to use the Insight and Learning Engine tools. It'll be available through February 2025. So that's traditionally when our subsequent release 26.1 is scheduled to come out. And so at that point, if you want to keep using the Insight and Learning Engine, you'll just have to go ahead and update to 26.1. Again, that's included with current active maintenance and support. So you'll then get some updates to that as well. Generally speaking, when we work with deep learning models of this nature, they are larger in file size. So we do not include them with the install by default, because if you're not going to use it, no sense in having it there just sitting there. But you can download the models as part of the installation process. This is typically what I do. It's just a little quicker from the installer. The final page of the installer has an extra downloads button. Click on that and you'll see all the additional things that you can install with the app. In this case, the Insight and Learning Engine is what you want. That'll take just a few minutes. It'll install everything so that you're ready to go and process and use the models. If you click through your installer way too fast, like I always do, when you attempt to launch the tools in Global Mapper, it'll say, hey, you don't have this. Do you want to download it? Takes a little longer in the app, just given the different download methods, but you can certainly download it in the app as well. But let's go ahead and take a look at some of the tools that we have here in Global Mapper. Let's take a look at land cover first. So land cover classification, land cover analysis, typically is, it's very often we see it provided by governments, state agencies, things like that. It's typically lower resolution and very large scale. One of the things we wanted to address and had feedback from was users who wanted to not only run their own land cover classification, but be able to do so on higher resolution imagery. And so the land cover classification models that we use are designed to achieve that goal. And we'll take a look here at what this model looks like and the processing it does. This happens to be a image from Central Park in Manhattan, so just kind of the southeastern edge of Central Park, I think. And we'll go ahead and run these tools. So currently this all runs locally on your machine. I think in the future it's a safe bet to say we'll be moving some of this to cloud processing. Don't quote me on that right now, but Right now, everything is local. By default, it's going to utilize, if you have a NVIDIA CUDA supported GPU, it will use that, and assuming you have, choose to install all the models, everything you need should be installed in that process as well if you don't have it already. We have a new deep learning toolbar that holds these tools. In the future, as I said, this is going to be continuing to develop and expand. We might see tools in different parts of the applications going beyond, just raster data. Expect this to be continually evolving, and very heavily so based on customer feedback. That being said, before I get off on too much of a tangent, many of these processes on the user end are relatively straightforward. The deep learning models are trained. There's no major settings to tweak other than making sure that you pick the proper model. The application should do that for you without issue. It'll identify the type of imagery that you're working with, and then you can go ahead and start your inference. This is a small data set, so it should run fairly quickly here, just a matter of seconds. And we'll see then that we get a new output data set that is a land cover map. If we go ahead and take a look, we'll kind of swipe between the data sets here. We'll see, here we've got our water, our trees. If we look down a little bit more, we've got our building structures, all the forested area in Central Park. We're even picking up trees along the streets, right, where there's trees along the streets and the buildings here. What I could do, and what I should have done probably, is turn on my map legend, and we'll see our legend for what we have. So we have water, tree canopy, other vegetation, barren land, roads, and other impervious surfaces, which makes up a lot of the portion of Manhattan here where the structures are. But so this is also a process. We'll talk a little bit more specifically about it in a minute, but also a process that can be fine-tuned and adjusted. So maybe for whatever reason you're working with a slightly different data set, you're not getting the outputs that you want, et cetera, you can fine-tune and retrain it so you have a model custom to your data. But let's go ahead and look at the next step of this process. Actually, I have another data set here, so I will just go ahead and open a different data set. So moving on from land cover to what's called object detection, where we find discrete objects in a data set. And we've started this process with building. So we have models for building extraction and vehicle detection. Those can be found in the object detection tool. And each tab here then corresponds to type of object: building, vehicles. Custom models we'll look at shortly, but they allow us to identify those respective objects. So we're going to start with, let's start vehicle detection. It doesn't really matter, it goes a little bit quicker. Again, very few choices here. It's going to pick the proper model that it needs for the imagery you have loaded, little description, and your layer selection. So maybe you have multiple layers loaded. You don't want to do all of them. The result of this process will be a bounding box around all the vehicles, and we'll zoom in and take a look and see how it did. So now each vehicle that it finds in the imagery has a yellow box associated with it that has its own layer, and we'll see it found 618 vehicles in that data set. Similar process for building extraction. Here, let me just turn these off for the sake of clutter. Okay. Similar process for building extraction. If you want, there's options to kind of post-process the output vector features. I'm not going to do that now, but you will always make a raster layer and a vector layer, and we'll look at those in a second here. We'll zoom out here. So what we're looking at here is a binary raster mask, just white is building, black is not. That's kind of an intermediate process. And then we also get the building footprint outlines as vectors as well. And we'll see here, what do we have? About 108 buildings that it found and created footprints for. Now, I mentioned a couple times fine tuning. That's the process of adjusting a model to better fit your data. That is often done via some type of ground truth, whether you do so manually or you reference external data. Right now, it can be done for buildings and land cover, and we will soon be releasing an update that allows us to also do this for vehicle detection too. The fine-tuning and retraining options can be found in the Create Model button here on the toolbar, and you can give it, a name, whatever you want to name it, and then choose what task you're going to be doing, building or land cover. Eventually, vehicles will be here as well. Couple settings to be aware of in this process, and for each one, you'll get a description below. Iteration is how often you make a pass through the training data to adjust the model. The batch size is another processing setting, how much of it is processed at once. Training depth, you can make generally lower or higher depth. Moving it to the left allows it to do a little bit more fine tuning closer to your data. To the right, the head of the model is kind of a little bit more generic level of a fine tuning. And then you could perform a full retraining, which will fully redo the model as well. And we'll see then there's no training depth options available to us. When we do this, it can be done a couple different ways. You could manually generate your own data, and the app's going to say, we don't have any data here. Do you want to do one? Or do you want to make some? So you have a tool where you can manually digitize and create control data. And let's just zoom in here for a second. I'll say, okay, this is my building. Great. I have a new layer and the features go into that layer. I could use that layer as part of the fine-tuning process. But maybe I don't want to sit and draw through all my data, and maybe I have some building ground truth from an external surveyed source. So this now is an external vector file, surveyed building footprints that publicly available, and I can use that as part of the training process. So I don't need to generate training data, I already have it. And when I choose start training, it'll initialize and it'll ask me what layers I want. So I pair my imagery with my ground truth. Maybe for some reason I also want to use the ground truth layer that I manually created. You can do that too. When you click OK, it would go ahead and run and retrain the model. We're not going to wait for that now because that's a computationally intensive process. It'll take a few minutes. But this is how you would go ahead and adjust those models. Obviously, I stopped things here, but I'm guessing, Mackenzie, it looks like we had a few questions come in. Anything we want to relay here? I'm sure there's a few about how all of this works and what's available to us.
Yeah, so these are, big new tools in Global Mapper. And one thing that we did have a question about is custom training for underwater data sets, maybe underwater imagery. So that would be, I think, a full retraining. Maybe you could expand a little bit on that.
Yeah, so the short answer is you can certainly try it now, but we're not at a point where we would expect to identify objects completely different from what the models were trained on. And what I mean by that is we have models generally designed for, we'll just say, buildings and land cover, and soon to be vehicles as well, that can be fine-tuned or retrained. If you were to attempt to find something completely different and completely different data, you'd probably have varying levels of success because presumably you're training on a much smaller sample size of data. One thing we are working on that, again, don't quote me on a timeline, is something more akin to a generic model where the model would be a little bit more adaptable. It would require users to provide training data, and then they could say, okay, I want to find my whatever type of object in this imagery. Here are some examples. So I think that a more generic model is coming, but for right now, I would say certainly give it a try, but I don't expect it to work on something as unique as underwater or, subsea data sets just yet. Also, I would plug that given that this is in beta, we are, of course, eager for all of your feedback on it. We've already had some great customer feedback and conversations from customers who are trying to do a whole bunch of different things with it. So if that's something that you're interested in and is in your wheelhouse, please feel free to reach out to us. We'll have contact information up on the screen shortly because that would be a great thing for us to work on together. Again, another question came in on cloud stuff. In the future, I see this moving to the cloud. I don't see that as short term within the next year or so, say. But I think that is something that's definitely on our radar. And going back to my previous comment, if it's something you are interested in, please reach out to us and let us know.
We also had a question come in asking about, if you have a large number of images, this person says they have 2 million images to search and process.
Okay.
Roughly how much of that would you need to do some fine tuning or training on? I know that's a tricky question, but I don't know if you have an answer or sort of guideline on that one.
So that a lot of that depends on so out of 2 million images, are they all the same sensor relatively of the same landscape at the same time? For example, one of our models is trained on a national US data set. So that's trained across the country. Are all of your images akin to that? Do they, are they all of, let's just say, for example, maybe you're looking at a farm. Is it all the same 100 acres of farm from the same camera, same flight type of day, whatever that may be? Or is there a lot of variability to it? The more variability there is, the more training samples you might want to provide, and potentially even just create a couple different models for each of those things rather than trying to pigeonhole it all into one model. We had another good question come in that I wanted to get. Can this be applied to point clouds? That is not the first time we've heard that question, and it is very much something that's on our radar. So I will plug again, if you are someone who has point clouds that you want to see analyzed in that nature, please reach out. Let us know. Why don't I just move our slides along here so we can get our contact information on the screen to help answer some of those questions. Before we do that, for those of you who do not yet have 26 Pro, you can download the app from our website. If you're in current maintenance and support or have any questions about your maintenance and support, you can reach out to our sales team that's authorized at bluemarblegeo.com. They'll be able to sort out all your licensing statuses. Any questions, Insight and Learning Engine or otherwise, please send them to our general support channel. That's geohelp@bluemarblegeo.com. They will be able to get those directly to Mackenzie, and I will be able to follow up with you. So I see, a few names here who have asked specific questions. Please send us an email, follow up. We'll be happy to discuss that with you. Anything else, Mac? I feel like we've really been rambling. I know we went over our hour here.
Yeah, I mean, we've gotten a lot of good questions during the session. Some great new tools, as Jeff said. We encourage you guys to, if you haven't already, upgrade to 26, check it out, try some of these tools, and of course, contact our technical support if you do need any help or have any questions about what Global Mapper cannot do or how to do something specific.
Great, and thank you for joining me as always, Mackenzie. It's always a pleasure. We'll talk to everybody soon.